say reversible reaction, now it is type of reaction that goes to both ends, idea, to both directions. Do you understand this? So now say that in every chemical reaction, there's what is called reactant, and there's what is called what now? Product. Idea. So let me have A plus C plus D. Idea. Now look at the question I have. A plus B will give you C plus what now? D. Now the first man here, this one is called reactant. This one is called what? Reactant. It's called reactant. Here is our reactant. While here is our what now? Is our product, right? Okay. Now, when I initiate a chemical reaction, at that point, that initiation is called the reactant, the particles. Okay, let me give a very good example. If you want to prepare soup, now, I don't mean, and you are going to get your okay, let's use egusi soup for example. I will grind the egusi, right? I will put it in one boil. Then I have my oboroko, I have my fish or my meat, any all the ingredients. I have my maggi there. I have my leaf. Of course, you are going to cut your leaf. Then you are going to have your oil will be there. So you are going to have all those condiments needed. Now all of those things are called they are called the reactants. You understand it now? Yeah. Now of course I cannot just come and start drinking red oil. It's not possible. It's not ideal. Now you say you want to now eat soup now. You now carry the oil. You put oil in your mouth. Put the egusi in your mouth. You now carry ogiri over and put it inside the you can see it's not going to make sense, right? Now, but all of those particles, all of those continents or ingredients that bring us for me to cook the food, all of them are called a reactant because at that point I'm going to be putting it at interval. At the required time. The time to put leaf is not the time to put your goods. It's not true. The leaf should be almost when everything must have been put inside. We just allow it to steam for maybe 1 minute. You turn and bring it down. Is it true? Okay. Now when you put all those stuff there, it is called reactant. Then when I'm done cooking, it is called what now? So that part of soup that end up producing is called what now? Now, when we now say that this reaction is reversible, when is it reversible? It means that if I start a reaction, which is reactant, if I start a reaction, when I go to this end point, then my ability again from here to still form the reactant, it is now said that the reaction is what now? Is reversible. Can you understand it? Do you understand what I said? Yes. Okay. Let me give an example. If I bring what is it called? If I get a salt, if I get a salt, then I add water, I'll get a solution of here. A salt solution, right? Yeah. Because at this point I cannot call it water, neither can I call it salt, right? Yeah. Now this is not a solution because inside this solution I'm going to be testing salt and getting water. Now, do you know that if I crystallize this solution, that I'm going to produce what? Salt and then water. Can you understand it now? Yeah. So as you see, I started with a particular particle of a particular species. And when I reacted this species, I was able to find a new species. Then when I now react it again, when I now react the product again, so in this case it means that if here this one now can be at this point that this one is serving as reactant. So that means this can be A plus B. This can be A plus B, giving us C plus what now? So at this point now, this is reactant, then this one is what now? But once the reaction is going towards this side, it's not going to be C plus what now? Will now give me A plus A. So I'm saying that in this case now, that here, this one that was product, with me, if I'm not going backward, if I want to go backward again to produce this man, that this C plus D will become my what? My reactant. Why this one becomes my rename? Are you with me? So I started with A plus B. When I reacted the species together, the substances together, I formed C plus D. Now every reversible reaction must have this arrow. One going to the forward, so from left to right. So here is left, This place is what now? And here is what now? Right. So the arrow that is going from left to right, and another one will now be going from right to what now?
Left.
Do you understand it? So reversible reaction is type of reaction that proceeds to both ends, to both direction. So I can go to the right, then after which I can also come to the beginning. Do you understand it? Okay, right. Please pause.